That screen doesn't look that good, does it? Do you have to use this thing?
That's for PowerPoint. This you can use that for scroll down.
Okay. Good morning. Yeah. Let's see. Okay. Today's the 10th, July 10th. See if I can run this. Today's code of conduct item that we're going to talk about through the following week is maintaining cleanliness and the condition of your vehicles and the equipment. That means is the inside as well as the outside. It's really a tough thing for the mechanics when they get something to work on and they have to clean all the trash out or move all the trash aside. So try to keep things clean inside as well as outside. Keep a good image on the outside, but keep it neat on the inside so you can be proficient at your work. Today we are circulating a sign-up for the Champlain Valley Fair, which is coming up. So we're going to be circulating the yellow sheet there. Did you put that out? Try to write it legibly so that Sarah can read it. And I think there's up to a pair of tickets, right? A pair of tickets for each person, or you can buy more if you talk to Sarah. But give her a call if you think of it and you haven't signed up on the sheet. Shoot Sarah a phone call or an email and let her know. Congratulations to Aaron. Aaron, are you here? Aaron Boisano. He's our newest project manager here at ECI. So congratulations. Been here 21 years. 21 years. Started out with Donnie. Okay. Okay, today's technical tip has to do with vertical curves. Many of our projects involve some type of transportation engineering, such as designing and implementing the traffic control plans, building and constructing the roadways, bike and recreational paths, constructing rail highway grade crossings, and rail or highway signal systems, and also lining and tamping of the rail. In the next few weeks, we're going to be talking about the different geometrical designs that are used and some of the simple forms of the calculations that are used to design some of the geometry of different types of things, such as vertical curves. And a vertical curve, if you think about it, an illustration of a vertical curve right here. In other words, when you're driving up the road, this is the vertical part. If you're driving up the road and you build it like that, it's going to be like the Dukes of Hazzard out there. You're going to be going over. It's going to be uncomfortable. It's going to be dangerous. Your car's going to be unstable. So what we do is we actually calculate the different elevations to put in the roadway for the grade for the profile to change the grade of the road so that it's smooth. And so that there's also a lot of parameters with vertical curves and changes of grades that you have to do that are this way as well as up and down, which is something different that I'm sure Ken is going to talk about super elevation coming up. But for the intent of this, vertical curve is just the smoothness. It's a way to smooth and transition between two different grades. The vertical curve, let's see. Chris Palmer will know this one by heart, right? The vertical curve is a parabolic curve which is mathematically represented by an equation, y equals ax squared plus bx plus c. So basically it's just a formula that we use when we calculate it, and y is the vertical component that you're calculating, and x is the position of where you are along the curve. When you plug in your position and you square it, multiply it by these constants, and then add the correcting factor, you will get different heights to add and subtract to the curve.
Fucking moose.
An interesting and valuable aspect of the parabola is that the grade change is consistent over the length of the curve. Specifically, the grade varies consistently from the approach grade to the final grade. So if the approach grade is a +4 and the final grade is a -3, you've got 7%. You got 7% of grade change. The interesting thing is over that 1,400 feet of vertical curve, the change per station every 100 feet is going to be 0.5%. So it's going to be a consistent change in grade along the whole entire curve. Design engineers select the vertical curve to provide a smooth ride, the necessary sight distances for stopping at the design speed, and also to avoid excessive cuts or fills to clear existing land features like river beds, floodplains, bridges, culverts, and of course rail crossings. The surveyor uses the vertical curve parameters of approach grade, final grade, length of the curve, and all the stationing for the cuts in the project. It's a head-on view of a vertical curve up and over. You can see it smoothly going up and over the rail crossing. If you get enough speed, you probably can get a little air on that. There's the other view. Ken also has some expanded analysis. If you want to get into them, go on the and click on this link, and it'll show you how to, so you can calculate your own. I know you want to do that. Some of you do. I know some of you do. The project profile of the week is the V-Trans IM 089-243. It's the I-89 bridge rehab down in Waterbury.
That's you, Daryl. That's you, buddy.
Yep, we're contracted with Becca and Belushi of Franklin. It's an $11 million bridge rehab project. Our scope is to do the bridge decks and the approaches in Stowe Street. The first phase of the work is reaching completion with the I-89 southbound bridge. The bridge is scheduled to open today. Is that going to happen, Daryl? Huh? They got pavement on
Our
it?
share is done.
There's the guys paving. I don't know what they're doing with the crane, but I guess that wasn't you guys.
Moving their own.
Yep.
Safety meeting, they have every Friday.
Here's the stats.
But off.
ECI installed 556 tons of asphalt at the southbound bridge. The bridge deck was paved with 200 tons, 2 1.25 inch lifts of Marshall mix, and the approaches contained 356 tons of Type 2 super pave, installed with 3 3.25 inch lifts. Did you do it that way, Daryl? Exactly.
It was 3 3.25 inch compacted lifts of Type 2, which was 500 ton.
500 ton.
And the bridge itself, bridge deck had 200 ton of Marshall mix, and they had the switch mix. We had the switch mix when we came off the bridge, and then they had 300 ton of super pave type.
Yep.
Or couldn't use the super pave on the deck.
So you had to do some.
Switch mid.
Wow.
4 times. You had to do it twice.
What's Marshall mix?
Marshall mix.
It's just the mix has got more liquid in it, fill in the void more.
More liquid.
Different
properties.
design.
Yep.
It's supposed to be easier to get compaction.
Glad you're here today, Daryl. If you have traveled through Waterbury recently, then you've been impacted by the new traffic patterns for the project. It looks like completion of the southbound bridge will involve a new traffic pattern to learn. The project is also a part of the V-Trans Smart Work Zone real-time traffic reporting. And Ken has a link here, but they have these stations where they have these little sensors. They can tell, they can actually see the views of the roadway, but also they can also judge. They have a way of determining your speeds that are going through your work zone. So they can sit there and look at their computer, and they can observe the speeds through the traffic zones. I'm sure probably in the future we'll see more of that on some of these other projects. So that's pretty cool.
Okay.
And the safety topic of the week, go back up to the top. Do you usually click on the,
I don't. You can if you want to read it.
right there?
Yeah.
See if it comes. Safety blog. Traffic accidents within a construction traffic pattern. There's been a lot of those lately. We're reminded by the motorists, this is right in the blog. If you click, you can get right to this from our email. As we're reminded by the motorist fatality in Berlin, Vermont this week, construction zone work areas, they're hazardous to both the construction workers and to the public. So it was close to where we were working. It was right there, and some of our guys responded to try to help out. So it was kind of a really tough situation for our people being there, but one of the people did pass away that was in that accident. It was a pretty terrible looking accident. I saw some of the pictures. As a contractor, we want to be diligent in maintaining the traffic control systems to provide our workers and to protect the public and to protect ourselves and protect our guys. As workers on the grounds, we need to be constantly on guard for errant motorists traveling through the work zone. And some of us have been hit by motorists. I've had my heels run over by a car one time, and some of the other guys here, I don't know if Harvey's here, but I remember Harvey got nailed one time. Guy actually came right through our cones. So it's pretty dangerous out there. So just keep your eyes open for that stuff. Everybody keep your eyes open. So, okay. Thank you.
I'll take it.
Yep. Have a good day.
Thanks, Ben. So that kind of brings us to just what we're going to talk about just on the safety side. We're not going to get into detail of the accident, but kind of just our responsibility in that work zone. You know, we have a liability to make sure we are doing what we're supposed to be doing according to the plans that we give to the state, even gets permitted that way, or we have to just follow the regulations. Because if we don't, and there is an accident like this happens, the company could be in some trouble. So just going to kind of quickly go over the traffic control plan, our emergency response, and just documentation this is the importance of just working in the traveling public. We do a lot of it. We're having, I don't know how many projects we have traffic control set up, or some type of diversion plan, merge, shifting lanes going on all in one day. So it's very important that we do kind of talk about this and making sure that we have the proper plan in place. And again, everything goes back to the MUTC. It's the manual on uniform traffic control devices. This is the regulations, how we properly set up a traffic control plan. It's all in this book. I know Daryl and Sean, they have one. The safety department, we have all these books. But again, if anyone else, project managers, would like one of these books to help figure out traffic control plans, it's in this book. There's these typical applications that are in this book that makes it very easy for us to properly set up traffic control plans. A lot of the projects that Daryl was on, and down in Berlin, those have to get approved because it's a state project that they're on federal highways. You have to have permits pulled, and you have to have those traffic control plans approved before you actually go up and set them up. But the ones that also could get us in trouble are just some of these flagger stations that we have, say on Williston Road. Those aren't, only internally in our system do we double check and make sure they're done right. So it's very important that we let everybody know when we're doing traffic control. We should always have a plan in place. I have a link here, and I'll kind of just show you what Berlin does on their daily plan. Massachusetts is doing a great job, and we have this new software that he sets up his traffic control plan, and this is actually kind of where they're working the day of the accident. The accident happened kind of out way down here, or where our work area is in here, and the accident happened kind of way down in here. So, they have this shoulder close, 500 feet sign, and then you can it's really hard to see, I'm sorry, but these are our barrels for our shoulder close. It's a three barrel taper, and then it's just down the tangent, we have barrels, just keeping the traveling public out of our shoulder. And then the same thing over here, you have proper signs. This is just a match line cut sheet that we have But you can see the barrels here. Again, it's another shoulder close, keeping just protecting our workers working in this area. Very high traffic area. So it's very important that we talk with our flaggers, we talk with the crew in that morning tailboard, and we say, hey, we actually can show everybody our traffic control plan so everybody has an idea what it's supposed to look, because if we deviate from our plan, we must document it properly. If something does happen and we deviate our plan, we have proper documentation, we could be held accountable for what potentially could have happened. For just basic forms, we can't always use that nice software. We have these forms set up in the safety room, if I can find them. These daily traffic control forms, it's just a generic form. This is something that we could do, and we really should be doing on the regular. And this gives you date, time, and weather, your route, where you're working, from where to where, posted speed limit, what kind of road type it is, your activity, 8-hour workday. Are you using flaggers? Who kind of performed it? This is something that usually the safety department, we kind of go over this. But again, if you're doing some long-term work, we want to make sure we have documentation of our traffic control plan. It's a very easy document to work. It even lets you know your sign spacing, your advanced warning signs, urban low speed, less than 40, greater than 45, your sign spacing, rural, and then on the highway. It's a very user-friendly form. You can find this on the shared drive as well, but it's also, we have them posted here in the safety department. And then on the back, you can do a simple sketch. You can actually draw it up, so then the crew can kind of take this form and then perform the traffic control plan perfectly. So this is kind of in the design, the thought process of planning our work out, is to have this form before the guys go to work and perform it. And then the last is going back to the MUTI book, is just the typical applications like I was saying before. And this right here, and that's why the MUTI book is great, is we can just kind of pretty much print out, or even on our tailboard, just write TA10. This is your typical flagger, two-way road with your typical flagger operation. You have your proper signs. You just got to add the sign spacing, which is very easy. You just got to determine, again, the mile per hours of the road determines the sign spacing. Pretty much if you're under 40, you're at 100 feet. If you're over 40, you're going to bump that up to 350 feet. But again, just got to ask the safety department or ask your project manager, and we'll get you all this documentation, because it's very important if something does happen that we have all the documentation we need to support our case that, again, this has just happened within our work zone. We didn't cause any accidents. So TA10, there's all the way up to there's 40 of these typical applications, and again, it's all in that book. In the back of the book, it's very, very user friendly to add. And then again, just with the emergency response, the guys down in Berlin did an excellent job. Again, any situation when you have like a collision like that, we want to call 911. But again, for anything less than if it's dangerous to life or health, you can just call the safety department. We can figure out, if it's a fender bender, stuff like that. But if it's a severe accident, again, call 911 if it's dangerous to life or health. Assist with possible. We are all capable of moving barrels and cones around, getting medical emergency equipment in our work zone. So try to help out, flag if we have to. Let's just make sure we can get a good corridor for the emergency response to get to where the scene is. And then again, if you saw anything, just the more information these guys have for what happened to the police officers, it only benefits everybody. And then please just notify the safety department if any accident occurs in our work zone. Doesn't matter how small it is, it's important, because if it ever gets reported to AOT, Vermont AOT, they might do an investigation on our work zone, and then we could potentially see fines down the road. So we just want to make sure we have all the documentation. And again, it's just the tailboard. Another great reason why the tailboard's important is what we're trying to accomplish that day, what kind of traffic control plan we had, the photos of our project, and then making sure we change our traffic control plan if we do any field adjustments in the field. And then any additional documents that we have, such as the approved letter or state, et cetera, that only helps us down the road if anything comes down the pipeline with any type of citations or fines from the state. It's a good, unfortunately, what happened, but it's a good kind of reminder for us to kind of, just lost my train of thought, to kind of tie down the hatches a little bit, to making sure we have all the documentation and we're not just sliding this traffic control plan away. We got to really make sure we're doing those. Project managers out there, look at your projects. Are we in the road? Yes. Do we have a traffic control plan? Could be as simple as easy as saying we're doing a TA10. That's a traffic control plan. But if we're doing something where we're more designing something that needs to be approved by the state, we're already taking care of it. But again, it's important that look at your projects, making sure that we have something in place and we have some documentation to go with it. And again, the point of this is to protect you guys in the field properly and the traveling public, because we've seen a rise in work zone accidents. What happened this week, there's been other instances, some really close calls out there. It's definitely an emphasis for roadway workers right now is people getting hit by vehicles. You don't know if these people are intoxicated. You don't know if they're texting. You don't know what's going on, health conditions. So really out there on the work zone, making sure we're setting up and stay within our barrels and cones, and then keep your head on a swivel, because you just don't know what's coming and how that person is traveling through our zones. I know we can take it for granted every day we go out, but we really need to just emphasize that it only takes a second and I talked with the guys in Berlin, they're like, it just came out of nowhere. They didn't expect anything, they didn't see anything.
Speed?
We don't really know the whole story, so I don't want to speculate. But it seems like both cars were kind of close to the center line, and one drifted over a little bit, too much.
Last year down there, 20 miles an hour on that bridge.
Yeah, that's right. You were down there.
I asked for a link off.
Yeah.
They set up. Same deal. Oh, we haven't got time right now.
Yeah.
Every day.
Flying through. Yeah. Speed's a problem. It really is.
Texting is a problem.
People on their phone's a problem. Yeah.
Last week, working there, the amount of people that go through flaggers and road signs.
Yep.
On your phone texting when they drive by you makes you not want to be out there.
Yeah. Well, again, if you see stuff like that, call me. Let me know, and I can at least call the police station. Hey, we got guys working in this area. They're seeing a high volume of people doing unsafe acts. Can you respond? At least you can try something. It's better to try something than sit there and not do anything at all.
Complain about it.
Exactly.
And this documentation thing, on that accident, we had to submit. Luckily, we had the documentation properly done.
Yeah.
Right.
Exactly. It was nice to have all the documentation in place. And again, Matt's right on top of it, and give it to the state police, because that's one of the first things they asked. Like, we want your traffic control plan.
Yeah.
We want your daily plan.
So if we didn't have that, we would have been scurrying
around. But again, and again,
verbally tell them what we did.
Yeah.
Right.
And the difference is this is an accident within a work zone is different than a work zone accident. A work zone accident is something that we might have created.
It's a fatality too.
Yeah. Plus, it's a fatality, and all fatalities, they do a huge investigation on it. The state police have their surveyors out there surveying the whole road, all the sign spacing, all the cones, everything. So, all right. Well, have a safe day out there. It's going to be a beautiful day. Let's continue. Be safe. Thanks for your time. Thanks for showing up. Everybody sign in, please.
Seriously? Oh, thanks.
You passed it out.
All right. Where's Rodney? Rodney. Every little bit, inch and inch.